Kia ora Year 9. This is the first video I'm going to do on what we call algebraic fractions. So these are a part of algebra that students need to do lots and lots of practice on. They're just like ordinary fractions with numbers once you get the hang of them. So start with these first three on this slide and pause the video and have a go at them. Okay, so the first one is nothing to do with algebra, only it follows all of the same rules. If I were thinking about that back when we did number and I had fractions, I'd know that I had some common factors in here. So we could divide through top and bottom by 2, and we could divide through the top and bottom by 2 again. And that would leave me with 2 times 2 times 2, right, which is 2 cubed. So another way I could have written that was to write, for this one, 2 to the power of 5 over 2 squared. And I end up getting 2 to the power of 5 minus 2. So I can just subtract the denominator index from the numerator index as long as the bases are the same. So we get 2 cubed. So things work exactly the same with algebra. If we look at this number 2 example, I've got a times a times a times a times a. And then down here, what have I got here? Well, I've got a times a, so that's a squared. So I'm going to simplify by dividing by a times a. So let's do that. And we're left with a cubed. Now we could have written number 2 like this, a to the power of 5 over a squared. And again, I've got the same base, so I end up doing this, a to the power of 5 minus 2, which is a cubed. So notice, big parallel between this one and this one. One's got 2 for the base and one's got a, but it doesn't matter. So applying that rule, number 3, we get a to the power of 4. So 7 take away 3. It's always worth checking with these ones, where is the weight of the a's? So this is a times itself 7 times, and this is only a times itself only 3 times. So we're going to have a to the power of 4, and it's going to be in the numerator. Let's try 3 more. Now this time, things are slightly different. We've got what I think of as a heavy denominator and a light numerator. But the same rules still work. So we're going to simplify by dividing top and bottom by 2, so cancelling out the common factor. And I want to do that again. Now then it looks a bit strange because I've got nothing left in that numerator. But actually I've got an invisible 1. So my answer here is going to be 1 over 2 times 2, which is just 1/4. Right, now that's, again, pretty icky. So, writing it all out, I mean. So we've got 2 squared over 2 to the power of 4. Okay, so here I've got 2 to the power of 2 take away 4, which is equal to 2 to the power of negative 2. And if you're in my class, we looked at these today very quickly, and we saw that we can think of negative powers as 1 over the ordinary old positive power, so 1/4. Right, now let's take a look at number 5, which is the algebraic equivalent of number 4. I need more room. Let me erase. No, I'm not going to erase anything. I'll just squeeze it in here. So we've got x squared divided by x to the power of 5. So I end up with x cubed in the denominator and just 1 in the numerator. Right, now let's see what happens once I get numbers in here. I can rewrite number 6. We can get rid of our common factors, and we're left with 2 over 3x. So that's when I've written the whole expression out like that, but once we get used to it we don't have to. So here we've got 2 divided by 3x, okay, because the x squared goes into the x cubed. So this question is exactly question 6, but using exponents. Okay, so just a couple more to try on the next slide. Right, let's try 36x divided by 9x cubed, 9x squared over 18x, and lastly let's try 25c to the power of 7 over 10c cubed. Okay, so now let's take a look at this first one. What common factors have I got in the numbers? Well, 36 divided by 9 is 4. So I'm going to have 4 in the numerator. Here I've got x to the power of 1 and x cubed. So I'm going to have x squared sitting down the bottom, because I can write in that to the power of 1. Right? And if I have to, I can think about those x's as being x divided by x times x times x. So once I've simplified, I'm left with x squared in the denominator. Right, on to number 9. Let's look at the numbers first. So I've got common factor, 9/18, so that's the same as 1/2. Now I don't need to write the 1. And here I've got x squared divided by x. So I'm going to have 2 sitting down here. And I've got 2x squared divided by x leaves me with just x. So my answer is just x divided by 2, which I could also write as half x. Now the last one, we do the numbers first, and we've got a common factor here of 5. Right, so that's 5 there, 5 5s are 25, and 5 2s are 10. I've got c to the power of 7 here, divided by c to the power of 3 here. So you can visualize that as being c times c, 7 times, and here it's just c times c times c. All I have to do though, once I'm getting comfortable, is just say, what's 7 take away 3, and that's 4. So here my answer is going to be 5 over 2 c to the power of 4. Alright, so now go and try the mathematics exercise on those, or do some textbook practice to get used to them. Thanks for watching.